So we're live. How's it going, Drew?
Nice. It's going good. How's it going, Charles?
Excellent, excellent, excellent. Long time no see.
Yeah, long time no see. So today, let's talk a little bit about what we wanted to talk about today.
Cool. What do we want to talk about?
So today we'll maybe take a look at the HTTP protocol or Hypertext Transfer Protocol, what that is, and how we might explore it together. And it's actually like, I think anyway, it's actually a pretty good, it's a pretty interesting place to start, I suppose, if you're thinking about like um, software and software development. Why would you start with HTTP? But it's also got an interesting history, I think, as well, because today, like HTTP, we use in a lot, like a lot of communication between distributed communication, right? When you have two applications that want to talk to each other, when you want to reach out and get information from a third party, most of the time, I would suspect that for sure, vastly most of the time, it's HTTP. But HTTP is not the low level protocol, right?
Yeah. I mean, like it's certainly become fashionable to use HTTP for creating APIs, right? I don't think it's all good. I think it's used horribly in a lot of ways, and I know a lot of people just use it because other people are using it and they just kind of go along with it, especially if they're earlier on in their career. But it's become kind of like that base that you build other things on top of.
Well, right. And so that was actually kind of what my point I was trying to allude to, I suppose, when saying it's not at the lowest level, right? It's kind of actually
No.
above other protocols. And so, but we kind of treat it, I think it gets treated as like a lower level protocol because people aren't looking below it very much these days. And that obviously has some trade-offs. But why don't we talk a little bit, maybe we'll talk a little bit about before we get to HTTP, maybe we'll talk about like what are some of the ways that we can communicate across a network.
Sure. So I mean, it depends on. I mean, you can get really low level. It depends on what kind of network and what level you're talking about. Like, some of them are going to communicate over like copper wires. Some of them are going to communicate over fiber optics. Some of them are going to communicate over radio waves or microwaves, electromagnetic radiation, kind of like the light you can see, except in frequencies you can't see. You can do smoke signals if you want. You can do carrier pigeons if you want. There's different ways of getting information like to different destinations.
This actually a little bit of a segue into a book recommendation, I suppose. But James Glick, he wrote a book called The Information, and I'm not sure if you've read it. He wrote another book, I think, that was a little more well received. He's a pretty good writer, I think, quite good. And The Information is sort of a history into a lot of things that I guess we'll be talking about today. HTTP is communication, right? And it's sort of the information is it's very much, I guess, a history of the study of information theory, maybe.
Yeah.
And it starts out with kind of talking about some of the early methods for communication. And when you said, smoke signals, or like, you have this binary communication that you had, like, say, in ancient Greece, where you could light a fire and that would signal miles away that war is coming. And then so another fire could be lit, and you could have this binary on-off, basically, signal. Whereas at the same time, and even earlier, in countries in Africa where they had tonal languages, and this, I think, kind of being the key, because their languages were tonal, which used like the inflection in sound to carry the meaning. They were able to come up with languages or drumming patterns that mimicked language, so they could actually carry on conversations across great distances using drumming. And I
Morse
thought
code,
maybe like Morse code, but Morse code,
just more
well,
ancient.
well, much more advanced, I would say, of a community, like much
Yeah.
more rich of a. I don't know, because I don't know it, but I would imagine like with Morse code, I guess you could call that tonal, but it's more like, you know, beep, 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 beep,
Yeah.
beep, right? Like it's not so much like beep, 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 right?
Yeah.
And so I think I imagine, and I guess it's difficult for me to properly imagine, not being fluent in any tonal languages, that you'd really be able to have a much more rich vocabulary and conversation in drumming. Like you might say, for example, like let's say we have a word like sun, right? So the sun, the sun of a man,
Yeah.
or the sun that's in the sky,
Yep.
right? There's ways to say that, and that's kind of interesting. But then I mean, it sets a context, right? But then there's these other things, and you notice it in communication habits, oftentimes from older people as well, but I guess younger people do it too. I don't know. I think anecdotally, I've tended to notice it more in older people, is that they'll say, and it could just depend on the person, they'll say the same thing several different ways,
Yeah.
and this adds this redundancy. And when it comes to programming for networks, network communication, redundancy often plays a big role. And I found that quite interesting. Anyway, sorry, that was a big aside to what we were talking about. And let's come back to, so we're talking about these different types of networks. And you said, this was fascinating, right? Because you said, yeah, sure. Well, we could be talking about fiber optics, but we could be talking about smoke signals. We could be talking about copper. So what's a network? Maybe we can start with that. What is a network before we talk about communication over a network?
I mean, like really abstract network. You have a bunch of things that are interconnected somehow, right? Like that's the abstract thing. And when you talk about computer networks, it's often like you have, say, computers, and these computers are able to communicate with each other. So they're sending information back and forth. Let me see if I can draw this a bit. Do I have a way of drawing? Hang on, let me see.
Okay.
Oh, quit it note. Okay, maybe I can do this. Hang on. My computer's spinning. Okay, let me just switch. See that?
Yes, I do. Yeah.
Okay, so you could have like if that could be a computer.
Not a
That could be
tomato.
yeah, tomato. That could be a computer. I'm just drawing them.
Okay.
I don't know. My computers are round. And then like you could say maybe that's computer A, that's B, that's C, that's D, that's E, and maybe these two can communicate each other. Maybe they have a wire connecting them.
Mm-hmm.
Maybe they shine light back and forth to each other. Maybe it's light we can't see, like radio waves or microwaves or something like that. Maybe this one communicates with that. Maybe that communicates with that. Maybe these ones all communicate. So not, sorry, not everything is.
Communicating directly.
Yeah, let me. Okay, there. Not everything's necessarily communicating directly with each other, but there's sometimes ways you can communicate, right? Like if E, which is on the right, wants to send a message to A, which is all the way on the left, it can communicate through B, right?
Mm-hmm.
But a network is like something like this. In math, you might call this a network, or you might also call this a graph, right?
Mm-hmm.
And it's just you have nodes, and in this thing, I've made the nodes circles, and then like the like the edges, like the things connecting the nodes, those lines or edges, those represent something like that connects them, right? In a computer network, it's like a line of communication. In other things, it might be a relationship, right? But let's not get into like kind of that kind of network. But
Sure.
it's often like in this sense, it's a way of communicating with each other, in some way, in some abstraction.
Okay. And so why would things need to communicate? Why would you have why would you need to set something like this up?
Oh, well, if I'm computer A and computer E has a movie I want to watch, I want to connect to computer E and watch that movie.
Okay, that's a pretty good reason, I suppose. And so either you could maybe get the file, probably you need to get the file somehow to
Yeah.
watch it. But
Yeah.
um,
Or
okay,
maybe you're computer D and I need to send you a message. So I send the message to you, right? Of course, I'm not directly connected to you, so I have to send it through B and go to D. Although if you were B, I could send it directly to you.
mm-hmm. Okay, interesting. Now, if we're all connected through wires, what would those wires be? What would that look like?
So I mean, there's different ways of doing it. A common one, what you might think is Ethernet cables,
Mm-hmm.
RJ, I think it's called RJ45. Um, that's a common cable used for networking. You could use whatever you want. Like, for example, like you have a bunch of wires in your house, like giving you power sockets, right? You
Mm-hmm.
can actually use that to create a computer network,
Mm-hmm.
and it's been done. Um, if they don't have to be wires, even like if you had a way of kind of like giving off light, right? And like for example, there's a kind of light you can't see, radio waves. It can go right through your floor,
Mm-hmm.
right? And you
So,
can
so
like
that actually might become, even though that's simpler than what we're talking about, it's
yeah,
actually far too complex to
yeah,
imagine in some ways, I think, than what we're talking about. So
yeah,
let's come back to a higher level, I guess, type of network
okay,
that is actually more complex, but somehow seems simpler
yeah,
because it's computers connected to each other and talking. So
right,
if we're connected through wires, then you might actually have some issues. You might have to use like a hub or something like that to connect them.
yeah,
Or um,
yeah. So
that,
if I was to draw this, how the hell do I refresh this? Um, let me get rid of this stuff. So
okay,
like that's a good one, hub, right? Because that's
yeah,
more common. So what that type of thing has is it has a type of like kind of like a super node, and you have a whole bunch of computers, and I'm drawing
mhm.
some computers.
And this would have been like I don't I don't think it's still very common today, but this would have been a very common type of office or school
This
setup. Yeah.
you do have this. I mean, like Wi-Fi works this way usually,
Oh
but
yeah, I
you
guess
don't
so.
you don't have the wires there. But like even
Right.
in my house, like one of the computers is wired to it. So this we'll just call it R for router, and then you have these computers like A, B, C, D, E, and you can see like the messages like A doesn't talk to B directly,
Mhm.
right? Because there's no connection there. A has to send to R and R sends to B,
Right.
right? Sometimes though with some of these devices, R doesn't just send it to B, R sends it to everyone.
Hmm.
And then they can see, hey, was this message for me? Like if I'm C and I see the message is coming in, oh great, there's a message. Oh, it's for
Right.
B, I'm gonna ignore it. But you can actually
So
just see what's there too.
certainly. So in this case, we're talking specifically about being wired.
Yeah.
And so if you're wired, what sort of communication protocol might you use?
Um, so at the low level for something like this, they're probably going to use Ethernet. Like that's a really popular one. It's not the only one.
Hmm.
And then on top of this is built like different abstractions, like other protocols, right?
Hmm.
Like if you get into internet, the base layer of the internet or part of it anyways is IP, right?
Hmm.
Internet protocol. So it builds it basically like you create IP for any type of network you're on, whether you're on a thing like what I have drawn, or you're using smoke signals, or you're using lasers that shoot, I don't know, to something else.
Hmm.
Like they all implement IP, and that means when you write a program, if you write something that speaks IP, right, like the IP protocol, not IP address for those that know that, the IP protocol, then it doesn't matter what's on the low level. It doesn't matter if you have a thing like I just drew. It doesn't matter if you're using carrier pigeons. It doesn't matter if you're using smoke signals. Like you just program for that, and then the translation happens there. That's kind of like how with your computer, if you have a printer, it implements what's called a device driver. As long as you can speak the language of the device driver, the device driver translates to whatever like native kind of hardware it has. Same thing with this. You speak IP, and then there's something there that translates it to the actual network, whether it turns into smoke signals or communications over copper wires or whatever.
Hmm. So, so you mentioned the IP protocol.
Yep.
You also mentioned Ethernet protocol.
Yep.
Uh, so if we look at like, I guess, we have this idea of things that can be nodes on a network,
Mhm.
um, somehow communicating with each other. So would you say that IP is a protocol for communication for nodes on a network?
You can think of it like that. The nodes on the network have something called an IP address. So
Hmm.
sometimes nowadays people call that they just say IP, but it has an IP address. Think of it like a phone number. I don't know if people are still familiar with phone numbers or they just use kind of like contact lists. Like you have the number that's assigned to your phone, and if I want to call you Drew, I'd call your number on my phone and it'd ring you, right?
Hmm.
Same thing with on a IP network. There's an IP address. As long as I know your IP address, I can call you, right? But I also need an IP address to make that call, right? In the same way, I need a phone with a phone number to make that call to you. Ethernet also has something kind of like that. It has what's called an Ethernet MAC address. So it has a you can interpret all these as numbers. It has a number that represents you on the network, and if I know that, I can direct a message towards you. Some of these things, though, like even though it's directed towards you, sometimes other people can see those messages, even though it's directed towards you. So it's, I don't want to say like it's just sent to you. I just want to, just to be clear and precise. Um, yeah.
So, okay. This is actually kind of interesting because the more I'm thinking it, the more I see there's some holes in my mind as well as far as like how this all goes together. Networking has not been my strong suit per se, but um, uh, I'm familiar-ish with like UDP, for example, and then like
Yeah.
TCP, TCP/IP, but I hadn't thought of an IP protocol as existing prior to like TCP/IP.
Yeah.
Um, did it exist before that?
To
Is
be
that a
honest,
thing like just IP without
yeah, I mean,
TCP?
like IP exists without TCP and without UDP,
Hmm.
right? So in the same way you build IP on top of Ethernet and other stuff,
Hmm.
TCP is built on top of
Hmm.
IP, right? But you can write IP programs without having TCP or UDP. For
Hmm.
example, if you've ever used ping on the command line,
Hmm.
that's another siren going by. Sorry.
No problem.
Um,
It's not that bad.
okay, it might get a little worse.
Yeah,
As it
make it a
turns
little
out,
worse.
I live near a hospital. Okay, it was actually a fire truck.
Yeah.
Um, so yeah, so if you ever use the ping program, right, to
Hmm.
see if you can connect to a computer, uh, that doesn't use TCP or UDP as far as I remember. Um, I don't think it uses just IP. I think there's another protocol that it takes advantage of that's very low level.
Hmm.
Um, keep in mind, it's been like 25 years since I,
Sure.
or not
So,
25,
so,
20,
so
22
so are
years.
we saying that like the hierarchy is sort of you have this Ethernet protocol, and then on top of that you have like an IP protocol, and then on top of that you'd have like TCP or
Yeah,
UDP, and then
yeah,
on top of that you'd have like HTTP.
yeah, yeah, basically. Although keep in mind when you're on the internet,
Hmm.
remember when you said Ethernet, it
Hmm.
might not be Ethernet. It could be other stuff too. So the Ethernet part, like anything below IP, could be
Hmm.
replaced with other stuff.
Hmm.
And that's one of the purposes of IP, so that you can replace that bottom layer and put anything you want, and you can use multiple at the same time. Like the internet, it's like many networks connected together, whether it's Ethernet or token ring or like whatever, right?
Hmm. Hmm.
That was one of the purposes of creating IP, was to be able to connect these different types of networks together to create abstraction on top, so that you use the abstraction. It doesn't matter what the low level network is.
Right.
Sounds like another fire truck.
Okay, so yeah, so that's pretty cool. So we should probably devote some time into each of those and at like kind of diving into that at some part in this series, I
Yeah,
think. But a lot of them are, and I think this is actually, I remember one of my first networking classes. I remember token rings was
yeah,
like one of the first things that we did, and I was like, I really wanted to build out like a network, a token ring network, and I didn't have access to hardware, and I didn't really understand it enough. I wanted to visualize it somehow to have it make sense, and it just I was able to read the material and do fine on the exams and stuff, but but I didn't actually get to play around with it enough at the time to have it really sink in. And now I guess after spending time, it started to make a lot more sense. But and I kind of thought back on it and thought, oh yeah, okay, well, that sort of makes sense. But it's not. I think it's not necessarily a great place to start. And I think a good place to start is somewhere where it's sort of like easy building blocks that sort of make sense that you can start to play with. And I think HTTP is a great protocol for that.
Yeah, I agree. Like, don't start with the complexity first.
Right.
Get something where, like, when you're learning a program, first you output something.
Yeah.
You don't worry about anything else. Like, you go backwards in a sense.
Yeah.
Okay.
So I think that's actually kind of interesting because, like, as we go higher level, things become actually more complex, but it's the abstraction, right? The abstraction over the complexity that makes it seem simple, and then you're able to do things that are potentially intuitive. So why don't we have a look at, like, what is HTTP? What is the HTTP protocol, or the Hypertext Transfer Protocol?
Yeah.
So I guess we say HTTP protocol, but that's like saying, Hypertext Transfer Protocol.
Yeah, exactly. So yes, I mean, HTTP is, I guess it's old now. It's been around for a while. It's changed quite a lot. Encoded into it is a lot of use cases that came up when people were using this in different situations. And it's not a perfect protocol. Like, if you get into it, there's all sorts of rough spots. There's all sorts of, like, warts and other problems to it. But it's ubiquitous. Like, it's everywhere. Mm-hmm. And I think that's part of the reason people use it, because it has support everywhere. But anyways, at least in the past, there was an effort to make it so that when a protocol communicated, like, you had the protocol working, a human could understand what's going on, right? Mm-hmm. And, well, how does that work in that case? Well, people made HTTP a text protocol, right? So what is text? Well, if you were to, like, take some of that data and look at it, and you look at it maybe in an editor or, like, some kind of viewer, well, you would see letters there that you would probably understand. And, like, they're English, though, just because the people involved with this spoke English when they were making it. But if you look at it, like, it looks kind of like English when you look at the protocol, right? And that was on purpose. And there was a bunch of protocols like that. It's not to say everyone agrees with that, but at least HTTP was created an era where, like, people felt that was important. Mm-hmm. And when you're programming this, like, you're writing a program, it makes it much easier to program this protocol when you can see English, and even to debug it. Like, why isn't this working? Well, I can kind of look at this and understand it. So I think a lot of people, they're used to the HTTP protocol with URLs, right? So let me just bring this up. So we'll kind of go. So they've probably seen stuff like this: www or HTTP : / I don't know if you can see that.
It's pixelated, so you'll have to make it bigger.
I don't think I can make that part bigger. Let me just bring this up. That didn't help. Can you see that? Yeah.
Yeah.
So they've probably seen stuff like this, right? And that's an HTTP URL. And then what happens when you do this, right? Well, this www example, that represents a computer somewhere. Like, it's a little more complex than that, but that's a computer. So in the same way, in your phone, like your number might be 604-555-5555, but I don't have to memorize that. And nowadays, I can just say, okay, let me find Drew, and then I just click on Drew, and then it calls you. It does that translation between name and phone number. In the same way, a domain name like this, www.example.com, will get translated into something like, an IP address, right? Mm-hmm. Right. And so there's this translation that happens. I find that computer, and then what do? Well, I speak HTTP with it. And actually, let me change this a bit so it's a little easier. Let's change it to cherry.html. So what does it mean? I go and I get this domain name. I change that domain name into what's like a phone number, an IP address that tells me where you are, how I can call you. and then I speak to you HTTP. And what do I say? I say, hey, HTTP, I want you to give me this. Give me that file. I mean, it might not be a file. It could be an application, but give me that.
Mm-hmm.
And okay, so let's see what that looks like. So I'm going to do a request here, and then I'm actually going to do it for real. So when I do the protocol, like, I'll just leave it here. We'll just like say what I'm writing below here is like the actual protocol. So what I do is I say, okay, so I want to get that. And just because of the way kind of HTTP evolved, I tell it, okay, get, and this
would you mind bringing your line up a little, like up to the top, so we can
definitely
see? Yeah, there we go.
So I say get, and if anyone's ever done HTML, they've probably seen get and post, and maybe if they've done some other stuff, they've seen these other kind of methods of like patch and delete and put, and like you can actually make up your own. So I say, okay, well, get, and this part here, right? That was the same as here, right? And this is just add that, right? That's just telling it, this is the HTTP protocol version this. So it's a way of versioning it. And then I go here and I type host colon. And what I do is I'm going to put this, what's in here. There's a reason for this. I'm just not going to get into it right now, unless we want to later. And I do that. And normally it would be just this. I need to put 2 enters. But what I'm going to do is this, just because, just for reasons I'm not going to go into. So this is like a basic HTTP request, right? I put get, I tell it what I want, and like here's, and remember what our URL looked like. Like it was this, right? So you can see like this part here, this right here. This is what your web browser does. This part here is right here, right? This isn't going to exist on the server when I try it, so it's going to give me a 404. But like, let's actually do this, right? So I'm going to do a little trick, because it's like, well, how do I run this? Well, I'm going to just run telnet. This is like a protocol people don't use so much anymore, although I like the protocol quite a bit. Interestingly, there's the reason people stopped using it because it wasn't secure compared to this other protocol called SSH, but there is actually a secure version. I coded it up a while ago, but okay, so here's a little trick. I'm just going to connect to the server on port 80, and we're not going to worry about what ports mean right now, but I'm just going to do this, and then I'm going to, actually, I'll just copy and paste it. Like I can do that. And I'll hit enter, and hopefully this works. Bam. Oh, 2 enters. Yeah, you got to do 2 enters. And what happened? Okay, so ignore this. Just this stuff here just comes out because I did use telnet to do this little thing. But if you notice here, I hope you can see that. This is what's over here, right? I copy and paste it. So this is me talking to the server, right? I'm talking to the server here. And then here, because like www.example.com does not have, /cherry.html. So what did it say? So this is its response, and this is what your browser receives in this kind of cases. So it starts off and identifies the protocol, the version of the protocol, HTTP/1.1, and why? Because maybe we have version 2 or 3 or 1.2 or whatever later on. And then what happens is there's a numeric code. So the responses have numeric codes. 404 is numeric code for what it is, and then it's a human readable text description, not found. Right, so this is a very common one. When what you ask for is not there, it gives you this. There's a bunch of stuff in here that matter that you shouldn't really care about right now, but these are just like headers. In the same way, like when I did this request, I was able to add 2 headers. Like, so what's a header? It's like key value pairs, like host. Okay, so I have something called host, and it has a value of this, www.example.com. Here's what connection close. So it's a common pattern, key value pair. Just so you know, like technically I could have more than one key. I can repeat the same key over and over again. Like link is a common one. So I could have link colon, then a value. Another line, I could have link colon, then value. So you can have more than one of the same header. So it has a bunch of headers that you probably don't care about now. I guess it's down here too. I should have went further. A bunch of headers. And then just because like HTML is used a lot. So you can see again, 2 lines, right? Like when I did the request, I had to hit enter twice, right? To tell it, oh, I'm done talking, right? Now it's your turn. and then it does this in 2 lines. And now what comes after that is the body, right? That's because sometimes when you do a request response, you get a body with it. Like if I did a post here, for example, right, instead of get, I would include a body. But same thing with this, like this response had a body. So headers, an empty line, so 2 enters, and then you can see a bunch of HTML, right?
Mm-hmm.
And there's just like a whole bunch of HTML, CSS, and it doesn't matter for us like what this HTML, CSS is, but this HTML and CSS would be taken and it would be displaying the page, right? And let's take a look at that, right? Like, what happens if we go to this, right? We see this actually.
Mm-hmm.
We get this, and that's what. Sorry, that's what all this is. When you render it, it's this. This is the code behind this, right? And this is what your browser does. Like, and you might think that's not complex, and like it's not. Like it's not complex.
The idea or I guess the basic premise is not complex, but I guess the more we dive into it, the more complex it could be. Like, how did it find the right example.com and so on?
Yeah, I think like there's a lot, like when you make these things, like even though a browser isn't that complex, it's a lot of effort to create it, right? Like, because you have to program a whole bunch of stuff. And even when you get into these protocols, like a lot of it's not complex once you've seen it, once you've had it explained to you, once you've kind of tried it yourself.
Mm-hmm.
But it takes time to go through all that. Like sometimes it's very involved. Like, you know, if we wanted to go into like how the hardware is made on the computer, right? We could go to the level of like transistors and how the physics works and how doping of silicon works and all that stuff. And you can say, oh, it's not complex. Well, it's not, but you have to spend the time to learn it.
Mm-hmm.
Right. So there's like an effort you have to put into, and like sometimes there's lots of stuff involved. So it might take quite a while to pick this all up.
Yeah, I think there's different sort of understandings from people. I think when they say something like complex, what they mean, or when they say hard, like that's not hard. It just takes time. You're like, well, how do you define hard? You know, like, and I think hard is actually a very funny, a funny word, because I was surprised. I think it was Robert Cowley or something like that who wrote one of the first dictionaries or sort of explanations of words, maybe 1180, something like that. Like, it's quite a while ago, and it was called like a list of hard English words. And I was surprised to see that the word hard, the slang term to mean difficult, was used that far back as a common meaning of difficult. And then I thought it through a little more, and I thought, well, I shouldn't be too surprised, because, you know, if you can imagine if something that people would do, such as, you know, if you're trying to cut wood, for example, if the wood's particularly hard, it's going to be more difficult than if it's not. You're trying to chew something. If it's particularly hard, it's going to be more difficult than if it's not. If you're trying to, you know, grind something, if it's particularly hard, it might be more difficult than if it's not. Whatever it is, right? Hard and difficult kind of go hand in hand, because, you know, it takes more time to get through something that's hard. It's not that your skill must be better particularly or anything like that. It's just that it takes more time. And I think that's actually sort of an interesting thing. Like, you don't necessarily require more skill to take more time. And I think maybe something like this, like the complexity of something, you don't have to necessarily be more intelligent, you don't have to be somebody who intuits things better than others to be able to understand that.
Yeah, but you can gain more skill by putting in the time.
Yes.
Yeah, it's also like, it's not just about where you start. Like, if you keep at something and keep learning and keep getting better, you will surpass anyone who has like just that like natural talent eventually. Like, if they're not putting in effort and they're just like relying on like kind of like whatever talents they had going into it, it's like you'll pass them. Like, if you keep on putting the effort in.
Yeah, so that's actually pretty interesting. All right, so let's come back to that. We talked a little bit about get, or we showed a little bit about get, and get using telnet. Telnet was a pretty interesting program, I guess, to use. But you said, but you could also use SSH. What else might you use?
So like what you're trying to do is find a way to create a because HTTP is built on the TCP protocol. So you're trying to find a way to make a TCP connection to a web server, right? And me using Telnet is a bit of a hack because I really shouldn't, because Telnet isn't just TCP. It does something if you send a null byte, right? Which will screw everything up. But I wasn't sending null bytes, so it was okay. There is also like the OpenSSL trick. I think I always have to look it up. It's like OpenSSL space -- connect or something like that. And then that would be used if you wanted to talk in HTTPS rather than HTTP. You could also write your own program. Like you could write a program to, that's probably like if you want to do something like really well, you create the TCP connection and then write code that would send all this, right? But it's a little more involved because you got to write the code, right?
Well, that's kind of interesting. So when you think about like HTTP is built on a TCP network, so then it is pretty advantageous to think a little bit more through what is a TCP network and how does communication happen on a TCP network if HTTP is ultimately TCP communication.
Yeah. So I mean, we were talking like we have HTTP here, we have IP here, and then in between that is TCP, right? And TCP presents an abstraction, right? Like, and meaning that it presents you a way of kind of interacting with this. And part of what it does is and like, for example, like with IP, you have packets. You have like these, like think like letters. Like I send you a letter, right? Like the days when people still sell, or like you receive a package. You've ordered something from a, I don't know, an e-commerce site, and you get a package that comes in, right? Like it's a discrete thing. You get one package and you get another package, you get another package. Some protocols are like that. You get these kind of, not packages, they call them packets, but you get these like chunks of information, a bunch of bytes together, right? And you would call that maybe packet oriented, right? TCP hides all that from you, right? It hides that packet nature. Because why? Because, well, like let's say I send you 3 packets, A, B, and C. You might get B first and then A later than C. And you got to reorder that. And what happens if you didn't receive one? You have to like call them up and find out where the hell it is and get it, right? TCP tries to deal with that for you. It actually is not perfect, by the way. Like some people just assume that all works. It doesn't necessarily work all the time. But anyways, it hides that. And like, what does it mean it hides it? Well, what it presents to you is that there's no packets. What there is just like a bunch of bytes, like bytes running forever, kind of like in a file, right? Like something like that, but like gigantic file, right? You just keep on sending bytes and just write more bytes and you receive more bytes. You don't have to think about packets, right? And that's what presents. And kind of like when I connected to the server, I just started typing. I don't have to think about packets, like when it gets sent, when it is, I just start typing, and it sends me stuff, and I send it stuff, and it sends me stuff. And it's just like a stream of bytes, right? And that's the abstraction that TCP presents. You don't have to worry about all the packet stuff. And that's why some people use it. Now, there's problems with it, but it's, it runs a lot of stuff.
It runs a lot of stuff. So the whole TCP IP protocol was largely considered, I think, to be sort of the birth of what we know as the internet.
Yeah. In some ways you can think of it like that. I think it was being used before or in the predecessor to like what we would consider the internet now. Although maybe don't quote me on that. Like it's like I said, it's been like when I was like looking into this like closely, it's like 22 years ago.
Yeah.
Something like that. But yeah, I mean, like it's the protocol of the internet. The internet protocol is like changed as you went by. Like for example, like some of these protocols are documented in these documents. Like they call some of them RFCs, which is kind of a funny name for it, request for comment. But they end up being specifications for this stuff. I had someone tell me this, so I haven't confirmed it myself. But
why do you think that's a funny name?
Oh, because like they call it a request for comments, but it's not treated as that. It's treated as like
A
gospel.
proposal.
Yeah, I mean that's really what it is. Like, hey, tell me what you think, right? But it's treated as gospel. Like it's the same
Right.
thing. Like I get it kind of an annoyance when people talk about standards. It's like you are confusing a standard with a specification. Like someone writing something down is a specification. That's not a standard. It's not a standard until people start using it like widely. But separate issue. But anyways, so there's these RFCs that are produced, and they're just specifications of like how this protocol works. One thing I was told is that if you actually implemented the protocol as it's in those documents, it wouldn't work. And it's because like the devices that you have like running the internet, like that make up, actually I shouldn't say running, comprising the internet, don't really work on that version anymore. Like they're different.
I think when you said like the internet as we know it today, I think you're probably talking about like the HTTP internet, right? Like the web.
Yeah, it's that, but there's also like other things like I mean, like some things, some of the protocols have changed a bit. Some new protocols have come about. Like we use DNS today, right? For domain names, like that wasn't always a thing, as far as I know. Like people just use IP addresses at one point. Then it's like, well, it's like on your phone. Like, oh, that's kind of hard to remember everyone's IP address. Let me use a English, like something that looks like English, right?
Which is kind of surprising because with phones we never really switched, and the technology just got to the point where we didn't have to anymore.
Well, yeah, I mean, you got kind of like these smartphones now that you have a contact list, and it kind of does the mapping.
It does, but you still have to enter the IP, right? Like you can't find my phone number based on my name. You can on your device, but you still the initial time.
Yeah, I mean, it's an effect of the way it works. Like actually, that's not true. What you said, someone has to enter it. The thing is, we share an address book. Like the way they solve that is that everyone in the world shares an address book. That's the domain name system. Someone entered that person's IP address. It just wasn't you.
Yeah. Okay. That is a good way of looking at it. Yeah. And I suppose it wouldn't be too hard to share phone books with friends.
Yeah, I think there's problems with the way what the domain name system evolved into. I think it would be better if it was more like the way we have it on our mobile phones, where it's not just like one person kind of like in control of it, leveraging it and like milking it for cash.
And I was going to ask why you think so, but I guess you've kind of told me.
Yeah.
That's very interesting. So I don't know how much difference that would make really though, because the way that we're managing our numbers on our phone, we still have those sort of singular entities milking the numbers for cash, right?
Yeah, but
like is that much different?
You don't have situations, for example, like okay, like someone goes and they seize. So let's say on my phone I have a number for Drew, like I have an entry for Drew. And then let's say someone else decides that, you know what, I'm going to replace where Drew goes to, right? It's not going to go to your phone number anymore. It's going to go to somewhere else. I'm like, what the fuck? Right. Oh, I shouldn't have swore. Like, you know, whatever.
I think I don't think you're not allowed to swear, but I don't know.
Yeah. Anyways, you don't have that, but I mean, you get that type of stuff on the internet, but also something like this, right? Like, how about like?
Do you get that though? Like, what would be the situation where that would?
So, for example, someone apparently this is ridiculous. They trademarked the word referee, and they were able to seize the domain of whoever had referee.com from them. I thought that was idiotic. Or like, there's other things like this. Like, I have an entry for Drew on my phone, and you have to go pay someone every year to allow me to have like Drew mapped to your phone number. And if you don't pay, then all of a sudden my phone number, it disappears and I can't call you anymore. Again, like that's idiotic, right? But that's the way like the DNS system, the domain name system on the internet works. I prefer if it wasn't like that.
How would you prefer it to be?
I would probably go more like decentralized. I guess that's the word people use now. Like for example, there are other ways you could establish identity. Like for example, like you go on some websites, for example, right? Like there can be multiple people with the same username, right? But you have ways of differentiating who you're referring to. And like if you want to refer to someone global, use something else, right? You can actually use some kind of like ID that's not human friendly, but then map that to something like that's human friendly within your system. For example, maybe you could use some kind of like public key, or you can use a hash from a cryptographic hash, or sorry, a digest from a cryptographic hash function, and use that as the specific identity, but then have a mechanism where in your code somewhere you can say, instead of like having that, I can say, well, Drew equals this, but I'm going to put Drew everywhere else to have something more user friendly. I would allow people to make that mapping themselves effectively, and even like maybe have ways of people sharing that with each other. But I wouldn't have necessarily one person controlling it. And you might say, well, that's going to create some problems. Like, yeah, there's trade-offs, but like it'll be more like our address books rather than like a global address book everyone looks up in, right?
That's kind of interesting. So it would be, yeah, I just wonder how would that, I wonder how that would play out, what that might look like exactly. So we could effectively have, like in my address book, for example, like I have a Drew that you might not have. And so my Drew maps to a different Drew than your Drew maps to.
So that means when you like one of the powerful things about that we have on the internet is we can point to stuff, right?
Right.
We do that through URLs. I mean, a URL is just a convention. You can do it other ways, but it's the popular way to do it. So if you're trying to communicate with someone with a different address book, you would have to communicate that with another way, right? You'd have to give a more low level pointer, right? It could be content addressing, it could be public key, it could be, lots of other ways. And then you would probably also want to say, hey, but I call this person Drew, right? And then maybe like you have ways of noticing a lot of people kind of like doing these mappings, like, hey, a bunch of people call this person Drew. They don't have to be the only Drew, but they're a Drew, right? And I can maybe include that in my address book, maybe knowing that I got this information from other people, not losing that, but there are ways of doing it. And is it perfect? No, right? There's trade-offs, just like there's trade-offs with the current system. It's another set of trade-offs, and I prefer those trade-offs to what we have now.
Okay, so let's come back to this whole HTTP thing.
Yep.
I'd initially thought, like it's a pretty simple protocol, whatever. And then I pulled up the RFC 2616, and I'm looking through, page 52, 84, page 116.
Is it that long? I've read it.
Page 144.
Yeah.
Page 161.
Is it really that
pages?
long?
170, 171, 172, 175. It looks like it's 175 pages long. So I don't think we're going to be reading through that together right now. But yeah, it's actually a pretty big thing. But I guess that goes through. Yeah, it's the whole thing. Fixed problem with this. This is the full sort of I guess conversation around it even.
Yeah.
There's all sorts of sections. So there's like basically as far as the headers or the table of contents. Yeah, it goes all the way through to 176.
Yeah. Yeah, it's like I think to understand it, like I would just like write it by hand, like the same way I did.
Sure, but this is, I mean, what we've just gone over here, I think would have been such a confusing and difficult introduction to HTTP for anybody who had no clue, and we've sidetracked a lot as well. You know what I mean?
Yeah.
We talked like at all various ends, and we made a lot of things over complex, right?
Yeah. I wouldn't even necessarily start with HTTP. I would probably like just do a communication where you can send one, like a bit of information from one computer to another.
Well, I mean, even that, like, that's hard,
Yeah.
right? Like a lot of the stuff's quite there's quite a few things that it sort of builds on top of. But what I was thinking was like HTTP, it is like, if you look at the full specification, then it covers a lot of things, right? Like what are you supposed to do in this case? What are you supposed to do in that case? How are you supposed to handle these types of errors? How are you supposed to handle those types for everything, right?
Yeah.
And it attempts to at least cover all of those things.
Yeah.
So that's good. But what we can talk about potentially is like the types of requests, right? Like what are method definitions? What are options? What is get? What's what's head? What's post? What's put? Delete? Trace?
Yeah.
Connect? You said you can make your own. What does that look like?
Yeah. So let's go into that.
What are the status codes? So actually, right here, if we pull up the yeah, I was looking for a good document on it, and I don't really seem to see one that is like the perfect one to look at. So let's just take a look at um, at that, like what I just sent there, the ietf.org.
I'm on. I'll bring it up.
Okay.
I'm on. You sent it on a computer that I'm not sitting in my lap. IETF. Was it the spec?
Yeah, ietf.org/rfc/rfc2616.txt.
2616.
Mm-hmm.
Switch. Is that legible?
Make it a little bigger if you could. Okay, that's legible. Yeah, it looks different from what I'm seeing.
I've got an HTML version rather than a text version.
Oh, okay, that's probably why. Let me go to the HTML version, I guess. All right, but I just wanted to scroll down to like the table of contents, and if you keep going down to around where it gets to about page 50. There we go. So you can see like some things like this. Like
It's not hyperlinked. Interesting.
Client behavior if server prematurely closes connection. Yeah. But the 8.2.4 part, what is that? Is that section should deal with it on the left-hand side. Yeah.
Just reading it.
That's interesting. So was it the same address but .html? Yes, yeah, it is. Interesting.
I don't know if you can see that tools.ietf.org/html.
Oh yeah, I got it. I just put HTML instead of TXT, and I got it.
Yeah. Yeah, I mean, like, I think like with some of these things, if you just read it, it's complex. It helps if you use it first and then you kind of get into it. Mm-hmm. Like, I think one of the things people spend a lot of time with are like, here, right? The codes.
Yeah, so that's probably worth talking about. I guess a couple of things that I would say would be probably the most worth talking about would be like CRUD operations and status codes.
Yeah. So one place where, I mean, because nowadays it's common for people to create APIs in HTTP or HTTPS. Mm-hmm. And I think for some people, like when they hear API, all they think about is HTTP, even though that's not actually what the word means or how it was used traditionally. But if if you're just kind of getting the industry, like this might be the only way you know it. So because that's so common, people often try to kind of fit this within HTTP, right? Mm-hmm. And HTTP was designed to do stuff kind of like what people call CRUD. Like, so CRUD stands for something. Create is the C, read is the R, U is update, and D is delete. So create, read, update, delete. It's also sometimes called bread, although they add a thing to there. Browse, read, edit, add, delete, add instead of create. And sometimes people will talk about what's called REST, which is really HTTP being used how it's kind of supposed to, or how it's intended to be used. There's no supposed to. How it's intended to be used.
What's the difference between bread and read? Browse and read?
So browse means you can see more than one thing at the same time. So read is a single item. Browse is get a list of items.
Okay.
So if you're doing that, if you're trying to fit those into HTTP, you would, for example, like you would have a URL, right? So let me just like switch this. So we have a URL. So maybe we're creating something, and like instead of www, we're going to put like API because we're cool and we want to put API. And we have example.com, and maybe we have users. And if we go to this, we get a list of users in some way, right? It might be an HTML, JSON, or something like that. But then we can also have a specific user 123. That's just like a number we've assigned them, right? And if we do a get on this, we might get their data, right? What happens if we want to update some stuff, right? Like, because remember, like we're doing CRUD, right? So actually, let's write it like this. I hope you can see that. So, this is create, read, update, delete. Okay. So in HTTP, right, we would do an HTTP get, and that would be read, right? So this is HTTP get. And then, actually, I can get rid of this. And then what do we do for create? The common thing to do is an HTTP post, right? And what you would do is you wouldn't do it here. You would do it here. You would do a post here, and then somehow it would tell you, oh, here's its ID. And then for an update, there's different ways. Some people use posts, but it's probably like what this is designed for, an HTTP patch is designed for update. If you want to replace the whole thing, you might do instead an HTTP put if you want to replace the whole thing. But patch means it's like a put. Like put means replace it, right? A patch means here's some things I want changed, right? And then this one's pretty natural. To delete it, you just HTTP delete, right? So if you wanted to do CRUD, right, create, read, update, delete, you would map those to these. And these are our HTTP responses. So if you're writing the server, right, like remember when I did the telnet, I was the web browser effectively, right? Like I wrote this code here, right? So if you're the one that writes this code here, right, like you see here, it says get, right? When you're the server, like over here, saw the get, right? And it responded a certain way. The same way, if you're writing this, you look at what's coming in here, right? Was it a get, right? Was it a post? Was there a post here? Was there puts, patch, delete? Based on that, I respond a certain way, right? And that's the way I kind of create this API. And that's it's just like you're fitting these ideas within the way HTTP is designed. And technically, you can create your own. Like if I wanted to, I could have like an HTTP punch or like HTTP kick or HTTP yell or like whatever, right? Like you can make up your own. But if you just want to do CRUD stuff, then
what's the point of making up your own?
Sometimes there's meanings to that, right? Like, I mean, you don't have to. I mean, like some people, they don't even bother with patch, puts, delete. They just use get and post, and everything's a post, right? And you just kind of like signal that information, that extra information, some other way, right? But like one way you can signal that information, because you got to communicate what you want to do. Another way to signal it is by just using a method, right? Like just do an HTTP like scream or HTTP run or whatever, right? You're just putting that into the HTTP method rather than like maybe in a body element or a query parameter or something like that.
And how would the receiving server know what to do with that?
You would have to write the code, right? So I mean, like when the request comes, like the browser or whatever is communicating is gonna like start off the request with that. Like I had it up here too. Right. So here's the request. Like instead of get, it could put post, or it could put punch, or it could put delete or whatever. Now, some of these, if you have that, you've got to put a body. So you got to like have stuff here, right? But then so whoever's making the call would put it here, and then the code on the back end would have to have a way of getting this information, right? Sometimes you do, sometimes you don't, right? And that's why some people don't bother with these other methods, because they either don't have a way of getting information, or the programmer doesn't know how to do it, right? There might be a way, they're not familiar with it because it's not something they've done before, right? And then once you get that, you can then do it. So I'll show one, but feel free to tell me like if you don't think it's worth doing. But I'll show one where you can get that information. So if you were programming in Go, for example, and like there's lots of different languages to use. I do Go now a lot of times. They have a like when someone like your server and someone called you, you're going to get a request.
Could you make it a little bigger?
Oh, yeah, definitely. Is that legible?
Yes.
Okay, good. So you're going to get a request, right? And this is going to come in, and you can see like when the request comes in, there's a method, right? So someone's going to make some noise because someone's coming through the door. There's a method, and I'm streaming. I'm on the internet. There's a method, and this method would store like the get or the post or whatever. So when you get when this comes in, the request, you would look here, right, and deal with this, right? So what does it mean to look here, right? So we can go on that too. Let me just bring that up. Oh, yeah. Okay, so I just want to copy and paste this. So let's say we had some code, and we're going to have like a serve HTTP method. Hopefully you guys can see that.
Yep.
And this is basically like when you think like when we made this request, I said this, and then the server responded. If you were writing Go code, what it would do is you would have a function like this somewhere. And there's going to be something that receives this and then calls your function, right? Technically, this could also be a method. I'm just going to ignore that for now. And then what you do is you have the request, and the request is this R, right? And I could call this anything as well. Like I could write out requests. I mean, that's sometimes better. Let's just put request. And then what you would do is in the code, you would have request, and then, okay, let's see what we call that. You can see here, we just call method. Okay, great. So dot method. And then what I might do is I might like have a code. I'll say, okay, switch. And then I would say, okay, so what happens if, this is a get? I would, do some stuff. What happens if it's a post? Okay, I would do some stuff. What happens if it was like scream? I would do some stuff. And what happens if it's something I didn't handle? And I would do some other stuff, right? And you can do that. And like what you would do eventually, what you want to do is that you would want to send it some information. So you'd want to send it some headers like we have here. You want to send it like maybe some HTML or something else. And in Go, at least, like this W, right? Like which we call anything. I'll just leave it as W. We would do something there. Like, so maybe like here, we might do, actually, I'll just do print. Or I guess I'm going to write to that. So, and this is just very Go specific code. Is this a pointer? Yeah, it's a interface. So I would do, I'm going to write this string to here. And of course, like that would just appear as like, wow. So it's not that useful. I actually need to write the header properly. I need to write these headers. Like it can't be just wow, right? So it need to be like, HTTP : like 1.1, like that we have here. And I don't want to respond like 200. Okay, maybe. And then I might need to do a new line and then put these headers in. And like, I need to write all this out, right? That would need to go in here. And then that would come out, right? But that would of course be my default case. Like, okay, so maybe this is the wrong place for it. Maybe it should have been under get, right? And it's like, I mean, I haven't like, this isn't the way I'd probably structure my code, but I think this lets you kind of see what's going on, right? Like here, we made a request, we said get, and we gave this. And of course, like also like an important thing is this this query, right? Like, what am I asking for? I would probably want to look that up, right? Like, hey, what do you ask me for? I'm not just going to do the same thing. Or maybe I do, right? Maybe I'm weird. But you'd want to look up this, like, okay, what method? I want to look up this. I might want to look up this. Like maybe I'm different websites, and like maybe if I go to www.example.com, I do something. Maybe if I go to something else, you do something else, right? And then like I can look each of those up, and based on that, I can decide what to do here. But in the very specific case of the methods,
Yeah.
it comes from request.method, and then I can use this construct, this switch, to basically like, okay, like if this is basically like, if request.method is post, I do this. If request.method is get, I do this. Like et cetera, et cetera. Mm-hmm. So.
Okay, so I think that actually sounds pretty good. I think what we can do is take this idea and let's write a small server to handle get, post, and scream, and then default requests.
Okay.
And make a small not right now.
Okay.
Like we'll do this as our homework assignment.
Okay.
And then so the idea is, can we write a server that handles using what we've learned here, a server that can handle post, scream, get, post, scream, and then a default. And maybe the default would be to return an error that you don't handle that type of request. Yeah. And then a way to test that. And that could be using Telnet. It could be using something else.
Yeah, I find, like, I mean, like I said, there's actually an issue with using Telnet. If you ever have binary data, you can hit it. But
well,
it's
personally, I've used curl or curl, whatever you want to call it, a lot for that sort of case. But I don't know, or wget even.
Yeah, so wget and curl are good too. The reason I use Telnet is because I want to write the HTTP request. I don't want wget or curl to do it for me. Like that's the whole reason I use Telnet, to be in precise control of it.
Right.
And that way, like if I'm trying to debug things, I can see what's going on.
Mm-hmm. That's pretty interesting. Yeah. So we can maybe explore that a little bit further next time. But I think this gives us like a kind of a good idea. We've bounced around a little bit, and we've talked about some of the different things. I was looking actually at page 51 in RFC 2616, and is where I was looking at it, method definitions, section 9. And so it says, like, here's a set of common methods for HTTP version 1.1. And although the set can be expanded, additional methods cannot be assumed to share the same semantics for separately extended clients and servers. And I thought this was really interesting. This is one of the ideas where, or this is one of the things that I remember so many books, like reading so many books, and it's just like, what are you trying to say? It takes a while for things to become obvious, and it usually, like, by the time you can understand the word, the text, you already know the concepts. And so, like in this case, what it's saying here, isn't this interesting? Although this set can be expanded, additional methods cannot be assumed to share the same semantics for separately extended clients and servers. All this means is if it's not following this, you can't assume, right? Or if you're using something that's not a common definition, you can't assume that it's been implemented the same way everywhere, because we don't know. It's like a custom function.
Like if we make up a scream method, and then Jack from Kansas makes up a scream method, we can't assume that he meant the same thing as us and it's going to work the same.
Right. Yeah, exactly. And I guess this is the way that they chose to write it, and it makes sense knowing that. But like, I don't know that if I didn't know that it would have made sense the first time. And then it talks about safe and idempotent methods. It actually, I believe this kind of stuff is quite worth a read, and even like what we just talked about is also quite worth a listen. But I think that it won't make a lot of sense until we show here's how you do it first. Yeah. I mean, so basically what we just said is like a homework assignment, but maybe we can come back and do something like that next week.
Yep, sounds good.
All right. So do you want to wrap it up here for today, or do you want to anything else you wanted to discuss?
No, I think that's good. We'll be back, and the sun's now shining in my eyes because it's bouncing off the building. Yeah. The curtain cable's over there, and I can't really get up right now and go change it.
All right.
So this is probably a good place.
Probably a good place then. All right. Well, thanks. That's it's been pretty fun, and we'll look forward to what we talk about next week.
It's good talking to you, Drew.
All right. You as well. Take care.
See you.
Bye.